Hi, I'm Paul Kyogan from GK Tuition, and in this video I want to talk to you about coordinate geometry of the circle. Now the question I'm talking about here is 2015 Paper 2 Question 4 Part A. In this question we're given the equation of a circle as x minus 1 to be squared plus y plus 6 to be squared equals 360. We're asked to find the centre and to find the radius. Now you should recognise that this circle is in this form. So this is a formula in our log tables that x minus h to be squared plus y minus k to be squared equals r squared. And if a circle is written in this form, the centre of the circle is hk. That's all information that I can get from my log tables. So you should recognise that means the centre of the circle is you change the sign of this number and you change the sign of this number. So with that in mind, clearly the centre of my circle here is just 1 minus 6. I change the sign of this, it becomes a plus 1, change the sign of this, it becomes a minus 6. To get my radius, you should recognise that the right hand side is r squared. So that means my radius squared must be 360. So if you want to think about it as r squared equals 360, which means that r is clearly the square root of 360. If you plug that into your calculator, that gives you r is equal to 6 root 10. And that's the form they asked me to leave it in. So they asked me to leave it in the form of a root 10, where a is an element of n. Or in other words, where a is a natural number, which means a whole positive number. Clearly 6 is a whole positive number, so I'm happy with my 6 root 10 and 1 minus 6. Okay, so for the next part of this question now, we're told that the coordinate k is the centre of the small circle. Okay, I already know the coordinate of b, and I'm labeling the centre of the circle S as, I'm labeling this as the coordinate S. So really all we're concerned with in this question are these three coordinates. The circle at the centre of the big circle, the centre of the small circle, and the point where they both touch. I'm told that the radius of the small circle is 1/3 of the radius of the big circle. Okay, so in other words, the distance from K to B is 1/3 of the distance from B to S. So you should recognize that means that the ratio, I can work out the ratio of this line. If the distance from here to here is 1/3 of the whole thing, then that means K splits the line SB in a ratio of 2 is to 1. 2/3 of the radius of the big circle is from S to K. 1/3 of it is from K to B. And we're asked to find the coordinates of K. Now, to be honest, probably the easiest way of finding the coordinates of K is to just do kind of a translation. Clearly, K is 2/3 of the way to B. So 2/3 of the way from 1 to 7, 2/3 of the way from minus 6 to 12. However, the most reproducible way of doing it is to use our ratio formula. So I want to work out this formula. So this is one of our formula from the coordinate geometry in our log tables. I want to know what is the coordinate of K if it divides the line SB in a ratio of 2 is to 1. Now this is the only formula in your log tables where it matters which one you label as x1, y1, which one you label as x2, y2. It's the only formula. It matters here which one is x1, y1, which one is x2, y2. So I always set my question up like this. I'm going to call 2 is my A and 1 is my B. Okay, so my ratio, I'm dividing it in a ratio of 2 is to 1. So I'm going to call A is 2 and B is 1. If this is my A, then the coordinate to the left of A is my x1, y1. So that means my x1, y1 in this case is going to be 1 minus 6. And if this is my B, then the coordinate to the right of it is my x2, y2. So this is going to be 7 and this is going to be 12. So now I know all the variables and I can actually just sub into my formula. So if I sub into my formula here, I get B times x1 is just 1 times 1 plus A times x2 is 2 times 7 divided by B plus A, which is 2 plus 1. This time I've got B times y1, which is 1 times minus 6, A times y2, which is plus 2 times 12, and then the bottom of my line is B plus A. Sorry, not B plus A, 2 plus 1. And again, you can just sub that straight into your calculator, do it in your head, and you work out that the coordinate K is the coordinate 5, 6. So the coordinate 5, 6 splits SK in the ratio of 2 is to 1. So that's my final answer for this question. Okay, so for B part 2 now, we're asked to find the equation of the circle C. You should recognize that in order to find the equation of a circle, you need the center and you need the radius. In B part 1, we worked out that the center is 5, 6. And in the information given to us in that question, we were told that the radius of the circle is 1/3 of the radius of S. The radius of S is 6 root 10. If I multiply that by 1/3, I know that the radius of C is 2 root 10. So if I know my center and I know my radius, it's relatively straightforward to get the equation of our circle. To get the equation of a circle, we're going to sub into this formula, where the center of the circle is HK and my radius is 2 root 10. So if I'm just subbing in here, I get x minus h, which in this case is x minus 5 to be squared, plus y minus k will become y minus 6 to be squared, and that's equal to r squared, which is 2 root 10 to be squared. Now, when you're asked to find the equation of a circle, you're not required to multiply out the left-hand side, but you are required to square the radius. So you're not fully finished until I square the right-hand side. So my final answer in this case would be x minus 5 squared plus y minus 6 squared, and 2 squared is 4, root 10 squared is 10, so this just works out as 40. So my final answer is x minus 5 squared plus y minus 6 squared equals 40. It's the equation of my circle C. Okay, so the last part of this question now, we're asked to find the equation of the common tangent at B. So I've drawn a rough sketch here. I want you to just realize the common tangent, this is the coordinate B. A tangent is a line that touches a circle in one place only. So the common tangent is roughly, it looks like that. And the other thing you need to know about a tangent is that every tangent is perpendicular to the radius at the point of contact. So if it touches it at B, it's perpendicular to the line B to the center. So the line that goes from 1 minus 6 to 7, 12. So I'm trying to find the equation of a line, or the equation of a tangent. To find the equation of a line, we sub into this formula. Y minus y1 equals m times x minus x1. You should recognize that in order to sub into this formula, I need to know the slope and I need to know one point. So clearly I know one point that's on the line. I know the coordinate 7, 12 is on the tangent. And I can work out the slope. The easiest way to get the slope is to find the slope from 1 minus 6 to 7, 12, and I know the slope of my tangent is perpendicular to that. So I know it's perpendicular to the radius. So in this question, the first thing I'm going to do is get the slope from 1 minus 6 to 7, 12, get the perpendicular slope, then I can just sub into this formula. So the formula for a slope is, the slope is equal to y2 minus y1 over x2 minus x1. So in this case, I'm going to call this my x1, y1, and my x2, y2. So if I just sub in here, the slope of the radius in this case is y2, which is 12, minus 6, divided by 7 minus 1. Which if we plug that in, we're going to get 18 over 6, which works out as 3. So the slope of the radius is 3. Now to get a perpendicular slope, you get the reciprocal of this and you change the sign. So remember, this slope is the slope 3 over 1. So the reciprocal of 3 is 1/3. So I know the perpendicular slope, or in other words, the slope of my tangent is, I get the reciprocal of this and I change the sign, so my slope is minus 1/3. So now I can sub into the equation of my line. To find the equation of this line, I know a coordinate and I know the slope. So I know the slope is minus 1/3 and I know a coordinate is 7, 12. So it's very straightforward now, we just sub in. So if I sub into my equation, I get y minus 12 is equal to minus 1/3 times x minus 7. Now to get rid of my fraction here, the best bet is to multiply both sides by 3. So 3 by the left will become 3y, 3 by minus 12 is minus 36. And on the right hand side now, I just have minus 1 by x minus 7. So it becomes minus 1x, minus 1 by minus 7 becomes plus 7. Now the question asked me to leave everything on the left hand side. So it asked me to leave it in the form of ax plus by plus c equals 0. Or in other words, just bring everything to the left. So if I bring my minus x across, it'll become plus, it'll just be x. I already have my y's on the left. And my numbers, I've got a minus 36 And if I bring my 7 across, it becomes minus 7. And that's equal to 0. So in this case now, my final answer is just x plus 3y minus 43 equals 0. And that's my final answer. That's the equation of the common tangent at B. So I want you to recognize there that even though we're in a circle question, that was a line question. That was coordinate geometry of the line. That's all material that could realistically come up at junior cert level. But I think a lot of leaving certs get confused when you would have been thinking along the lines of a circle there. Oftentimes, if it asks you to find the equation of a tangent, I want you to recognize that a tangent is just a straight line. So oftentimes it's solved by just using the coordinate geometry of the line. So I hope this video made sense. As always, if you're unsure on any of it, then just let me know in class and I'll try and explain it differently.